and mapping data flows in particular, is will it replace the traditional processes currently being implemented out in the market? So what I mean by traditional processes is using things like Python, Databricks, any sort of Jupyter notebook code that's being run, right? So with that, I'll just get started and I'll cover the agenda for tonight. So basically, I was going to introduce myself, but I think David's done such a good job. I'll share my contact details and basically how you can follow me as well. And so basically that question is the one that I wanted to answer as part of this. It's not so much it is a topic I wanted to raise. I do not have the answer to that question yet. And I'm hoping to get some of that feedback from you guys. So I want to see if we can make it as interactive as possible. So I'm happy to share your thoughts. Okay. So what we'll do as part of that, I'll take you through mapping data flows as a quick introduction. I'll take you through Azure Data Factory. I'll show you as part of my demos how to build a mapping data flow. Using that, we'll run, like I said, quick demo, some of the pricing considerations that you'd want to take into account while building them, and some of the advantages that I think you will get out of a mapping data flow, and some of the disadvantages that I see that you will encounter as you go along. Okay. So as I said, I'm a data strategist and a cloud solutions architect. So if you want to reach me, you can reach me on Twitter, you can reach me on LinkedIn, or you can reach me via my blog. I'm starting to write blogs a bit more frequently, but and I'll keep them updated as much as I can. If you're interested in getting certified as a Azure Solutions Architect or a Google Cloud Architect, I've written articles on how I've sat my exams. And if you want to just find out about what topics I covered, how I've learned, what is the best way to go about it, I'd suggest having a look at my articles. Okay. So why the topic on Codeless ETL? So like I said, there's a few reasons why I wanted to raise this as a topic. Now, if you think of a few years back when cloud kind of became ubiquitous across IT systems, almost everybody who's using SQL Server pretty much had this argument going on: is should I use SSIS to run my ETL, or should I use SQL Server Stored Procedures? I've had this debate many a time with lots of principal consultants. I've had them with my managers. I've had them a lot of people. Okay, so what is the best way to write stored procedures so it performs well? Not only that it's accessible so that anybody who's not well versed in SQL can go ahead and write them. Now, previously it used to be SSIS data tools or data flows within SSIS that you used, because it had a visual component. You can drag and drop them. You can configure them in and what was your uncle. Problem with using data flows at the time was it was very bulky. You had a lot of bugs. And yes, you could get business users to actually start working with them. But again, it became a lot more cumbersome. There was a lot of background knowledge that they needed to have. And it wasn't very conducive to the business users. So when I started using Azure Data Factory, I had the same sort of dilemma. Now, the reason for that dilemma, so if you look at Azure Data Factory currently, or even when I started, primary option you had to actually develop and deploy code into Azure Data Factory was to write stored procedures and call those stored procedures within Data Factory. Okay. So just to give you a brief introduction of what Azure Data Factory is, before we go further, it's pretty much a data orchestration tool. What it does, it basically says, I will run each of my components as individual pieces of code. What that code is can be done in parallel to while you're designing your pipelines. So, but that was still writing code. Now, then you have the added complication thrown into Azure Data Factory with the introduction of Databricks and Jupyter Notebooks. Now, yes, you could write your components, in a collaborative fashion. You can do them parallelly. You can do, multiple people could be working on it at the same time. But again, it was code. Somebody had to sit down and write a piece of code. Now, with all that it entails, so the bugs, the management, the processing of it, etc. So when I first moved to Brisbane, one of the projects I started working on was implementing a data warehouse from scratch. And at that time, the mapping data flows was just coming out of beta and hadn't even been made generally available yet. So as part of the solution, we said, look, we will try and we will attempt to use mapping data flows. And I'll give you a brief introduction of what it is shortly. But that's how the journey got started. So as I was saying, it's now and going forward, it's going to be a question of, is it Databricks code? So is it Python? Is it Scala? Is it C#? Is it .NET? Or is it mapping data flows? And that's going to replace the old question of stored procedures versus SSIS. Okay. So what is an Azure mapping data flow? It's a component of Azure Data Factory. So I think it's been out since at least the start of the year, if not earlier. I think it's the start of the year from memory. It's based on Spark. So it's pretty much the same code base that Azure Databricks is using. Okay. Obviously, as everyone knows, and if you're not aware, it's a popular the big data technology that runs on Apache. Okay. But what it does provide you that Apache, the Jupyter Notebooks doesn't, is a visual development environment, which is similar to your SSIS and data flows in SSIS. So for a business user or for somebody who's getting into doing Azure mapping data flows, it's a great way to get in and design your code without having to know a single piece of code, if you get what I mean. Okay. We'll ignore that one. I think it's the same thing. So what I'll do is I'll take you through some of the pipelines that I've built, just a couple of simple ones, and we'll see how easy it is to design one. I guess before I get started, are there any questions so far?
Yeah, nothing in the chat so far.
Okay. Cool. So what I'll do then, so let me switch this over. Okay. So as you can see, I've got an Azure Data Factory component running on my screen at the moment, or a pipeline, or an instance, whatever the case may be. I've got two pipelines here, and I'll take you through what each of the pipelines does in just a second.
Yeah, we can just see the demo slide, not your actual screen.
Okay, thank you. Let me stop my screen sharing, and I'll start again. Okay, is that better?
Yeah, can see Data Factory now.
Yep.
Okay, perfect. So I've got a few simple pipelines set up. So I've got two pipelines set up, and as you can see, I've got two data flows set up as well. So all my pipelines are doing at the moment is calling a data factory flow in here. Okay, so the first one, basically what it does, what it's set to do is basically copy a set of data from your source to your target table. There are no transformations, it's a straight out copy, okay? So all the pipeline is doing is orchestrating a mapping data flow. I'll come to the reason for that in just a second. If you look at the, okay, if I look at that one, which is what it's calling, like I said, so it's looking at the source data, which is in this case is the employee table coming out of the AdventureWorks database, and it's putting it into a target location. So one of the things that this does provide me straight away is the ability to do samples. So if you're running tests, if you're doing development, you can set that row limit to a low number and run it. So if you have a very big database that you're wanting to copy, you can limit what you're doing. You can do drifted columns from your source table, so you can have your source systems change, but still manage to hit your ETL targets. One of the headaches when you were using SSIS or some of the other on-premise ETL tools previously was if you had schema drifts, then it was a massive pain trying to go back and try to re-engineer everything. Whereas mapping data flows gives you that flexibility out of the bat to actually get that sorted out. Okay. So as you can see, I can limit it once you can set it up so that you can set the batch sizes, you can set your isolation levels. Everything can be done here. It's all visual. You can set up your target types. You can look at projections and everything else. Now, one of the things to also take into account, my source system at the moment is a database server. You have a couple of other options, obviously. You can write it as CSVs, which is another popular way to actually ingest data into a data warehouse or into a big data system that gets written to a storage environment. You can pick it up the storage file, and you can roughly guess what the data type will be without having to manually set it in your source. So how would you do that? You'd select it, come here, and you would just go either import projection, or there is an option to do detect source data type when you pick it up from a source file. And what that'll do is the Azure this data flow will go into your data, and based on what it can see, it'll give you a best guess approximation of what data type it needs to be. Generally, I've found it to be fairly accurate based on your data, but if you have, say, a sample of 1,000 rows coming in, it'll be based on those 1,000 rows. And if it finds if one of the data types in your rest of your data set doesn't match the data source type, that's when you'll get the error. But it is possible to do this. Okay. So the partition options, I'll get into at a later stage, because that comes down to your performance when you're loading into a Azure Synapse Analytics. If you're loading it into Azure SQL DB, and if you don't have partitions, it doesn't make as much sense to use them. But again, when you're coming down to performance tuning, and if you want to eke out every single bit of performance, then you can. And this is one of the ways to go about them. Now, this one here is interesting as well. So it'll obviously give you the columns, it'll give you the source types, everything else. The reason I say it's interesting, not so much in the source, but in the target, and I'll show you that shortly. It'll tell you for each column and each data set what type of operation is going to be performed, whether it's going to be an insert, delete, or a update. So one of the other things you can do, and again, this is a simple scenario. I'll take you to a more complex scenario and show you the benefit of it. You can do fetch your data. So what this will do as a quick debugging exercise, if you want to see what's happening with your data, if you're getting any information, if there's anything wrong, this is the first place you'd go to check. Okay, so as you can see, you have all this data coming in. This is what you expect, and you can do your quick sanity test to make sure this matches what you have in your source systems.
Yep. Hey, we just had a couple of quick questions in the chat. So
yeah.
One of them is just about, is this all cloud, or can you connect to an on-prem data source?
Okay. So yes, at the moment I'm connected to all cloud sources only. You can connect to on-premise as well. I have done it before, and I'll show you how to connect it to on-premise servers as well. And I'll show you a couple of other options that there are available that you can use within this. Okay, I'll go through that as well.
Yep. And one quick one from Craig is, what are the benefits of using mapping data flow versus, just the native ADF copy data component that comes up on the main screen when you get into ADF.
Yes. So when you're using the copy data tool from ADF, within ADF specifically, and not mapping data flows, you can copy it. You have to write SQL statements. You can run store procedures, and that sort of thing. Here, it's a full it's a full ETL process where you can do data aggregations. You can do change tracking. There's a whole bunch of additional context that you can put in. And one of the best ones that use cases for this that I found that doesn't exist, at least as far as I'm aware, in pure Azure, is the inferred data column types, drifted column types, and the schema drift as well. So the schema drift, pretty much like I was mentioning before, if your source data schema changes for whatever reason, in the traditional ETL world, or if you're using Azure Data Factory proper, you have to go in and re-engineer some of your work to make sure you can get in that extra pieces of data. It's a manual effort, and it takes a little bit of time. Whereas using mapping data flows, it's pretty much catered for you. Okay. So if you look at the next settings, which is my sync. Okay. Just to define terminology here. So in ETL, we pretty much had a source system and we have a target system. When we come to ADF, any big ETL pipelines, it's your source and it's your sink. Sink is your target data warehouse, okay? Or any system. It doesn't have to be a data warehouse. It can be, machine learning code. It can be AI. It can be, anything like a NoSQL database. I'll show you the connectors that are available as well shortly. But it can be a whole bunch of connectors. It doesn't have to be a database. I've just built it using a database. Okay. So if you look at your sync, you've got a whole bunch of options that you can do. Previously, this is what you had to write a whole bunch of SQL statements, put them into SSIS as SQL tasks, either calling a store procedure, passing in variables, that sort of thing, to say, delete my data, update my data. This is all visual. You still have the option of actually setting up a custom SQL script that you may want to run as part of your ETL process, either pre-execution of this pipeline or post-execution. Okay. So one of the things you will see here, so mapping is interesting for two reasons. So what it's doing at the moment, if you remember to SSIS, you would have a source system, you'd have merging of two systems. You'd have the same column names in two, and SSIS would throw an error saying, I've got two systems coming in. One of them needs to be deleted, or you need to remove one of them. Here, by default, these two options are set, whereas if you have duplicate columns coming in, it'll ignore one of them. Same thing with an output column. Okay, so what it also does, based on the names of your tables, so if you have the same name in your source and the same name in your target, it will auto map them for you. You don't have to go in and map them. Okay. Now, I typically tend to leave this on because I don't have to worry about mapping. All I need to make sure is my columns match up. If you want to call your column something different, or if you want to say, I've got, say, 16 columns here, I want to delete 10 of them because they're not needed in my target, you can turn that off. You can go and manually delete each of these columns as you need to. If you don't want to make this change, then you can reset it.
Hey, Sarah, sorry to interrupt you. Just to extend the question from before, maybe so I think when you said that with a standard copy activity, you will need to write the store procs. Is that because if you want to do a transformation, that doesn't allow you to transform the data while copying it?
Yes, that's right. So if I look at this, if I'm copying it to this, yes, you can do a pre-copy script. But if I want to do any post-processing of this data, I can't do it within this copy. At least not that I've been able to find.
Okay, so and therefore you'll need to have like something after this step that transforms the data.
That's right. Yes. Yeah.
Okay. And is that for those one who recently joined? Is that different from your traditional ETL that you were explaining before?
So in traditional ETL, so if you were using SSIS previously, you had the same sort of problem. So you either had to write a SQL Server stored procedure to do your aggregations or any calculations for you, or that almost always went into a derived task in SQL Server SSIS. Okay, it's pretty much the same concept. It's just handled a little bit differently.
Okay, is that one the one that they say that is instead of ETL is like a ELT approach?
Yes. So I think the ETL process, which is your extract, transform, and load process that used to happen quite a lot, say, at least 2000s to 2010 onwards, slowly morphed. Almost everybody that I know of at the moment is going to do a ELT process now. So that's kind of the de facto standard. So you extract your data, you load it into a system, then you perform your transformations.
Okay, thank you for clarifying those points there. Thank you.
No problem. I'll just delete this. Okay. So if I go back to this copy, okay, so that's your mapping information. Again, you have your optimized partitions based on what you need to do. Now here you can have a look at what your input column is and what your output column is, and you can have a look at your data types between the two. So if there's any discrepancy, then you can go ahead and change your database schema as needed. Okay, this is a good way I've found to quickly eyeball my database systems while I'm doing the load, just to make sure I don't run into any problems. Okay, so last thing I'll also show you, which is quite good, is one of the things that you always run into as a data engineer, as a data professional, when you're transforming data, is quickly having an eyeball of your information while you're doing your debugging. Yes, what traditionally used to happen when we were running ETL, you would design your process. If it was stored procedures, you'd run the stored procedures, then you'd have a look at your data. Problem with that always was that it would go into your database systems and you would have to roll it back. In your dev systems, it wasn't an issue. If it was in your production or your non-production or pre-prod environments, then that was a major problem if you're doing major ETL checks as well. So to resolve that, what mapping data flows provides you while you're debugging is the ability to view your data at the end of your process, at each of your processes. So as you could see, I could have a look at what my source data is coming in. Okay. And I can also see what my target data is going to be before it goes into my database server. So if there is a discrepancy between the two here somewhere, it's immediately obvious during development that there is a discrepancy. Now, again, just a caveat here, this only depends on the number of rows that it's trying to actually show. So by default, for performance reasons, it limits the amount of data that it gets in. You can change them, and I'll show you how to in a second, but it's bringing you a sample. It's not giving you the entire data set. That's to prevent, if you have a terabyte size table, we don't want the terabyte size table loading up during debug sessions. That's the only thing it's trying to prevent. Okay. So that's the first demo that I had. Are there any questions about that? Okay. All right, I'll keep going. So one of the things that, okay, so like I said, so if you look at this mapping data flow, in and of itself, it is meant as a design and canvas. You can define your process, you can go in, you can do data previews, but what this will not do is it will not run your pipeline. So there is no risk of you actually updating your data somewhere, whether it's your dev, whether it's your production, whether you can run this safely to see if there's a problem. Okay, without impacting anything else. What you would do to run this pipeline is you would come into, or to that data flow, is you would come into your pipeline and you would execute this. So the way I've done that is pretty much drag my data flow on here, creates a copy, And when it runs, it executes this. Okay. There's a couple of other things. I'll go into some of these settings for you in just a second. Okay. So if you look at the execution of that particular thing, it'll give you the number of records that were loaded. It'll give you the partitions. It'll give you how long it took to load. Okay, I'll get to some of these columns as well. So you've got total columns coming in from your source system. These are your new columns that you've added. Updated columns is pretty much if you've changed this name or if you've got drifted columns coming in, that sort of thing. Any columns that you've deleted. So you've got full audit trail while you're doing development and execution of your mapping data flow to say what is happening. Now this information can be extracted and put into a database as well. Yeah, I haven't gone into that in for this particular demo, but there are articles out there that will take you through this. And again, so if you look at this as an example, it gives you the target. It'll tell you what the source name is, whether it's mapped or not, whether it's drifted, and it'll give you information as to what it's done. If you look at that again, so if you click on this. So this particular pipeline took 816 seconds to run, 570 milliseconds to start up, and 290 rows that copied across. So you can tell straight away at a glance at your first execution that this pipeline is doing what it's supposed to. Okay, two other things to note. So one of the things you will run into when you're doing mapping data flows. So what it does, so when you run this pipeline, it stands up a Spark cluster in the background for you. Okay, so the standing up of that Spark cluster has two ramifications for what you're doing. What I mean by that, so the Spark, when it's trying to stand up a Spark cluster, it's standing up a VM in the background. The VM by itself takes about 5 minutes to start up. Okay. Or 5 seconds to start up. So you will always have a lag when you run your mapping data flow, especially your first one. Okay, I'll show you. There's a couple of options that you can set to actually improve your processing time, and I'll show you what the default one that comes out of the box is and how we can improve it as well. So that is the big thing to keep in mind. So if you're running only one mapping data flow, you expect it to the data is 219 rows. You expect it to finish, very, very quickly. You notice that it's taking you, 6 seconds, 7 seconds, in this case, 10. The reason is part of that time is meant to stand up that cluster. So it is by design. And I know I got caught out by it quite a lot when I was actually starting working with this. So that's something to keep in mind. Okay. So if I go back to the mapping data flow for a second, so as you can see at the top of the canvas here, so I've got two things. So I've got validate section. So it will validate your entire mapping data flow. I suggest if you are trying to go down the mapping data flow route, please use it as often as possible because it's very good. It's your default error checker, warnings, anything that you need to take it care of will be given here. It is very good. It'll give you an error. It'll take you to that error, and it'll, you can try and fix it as much as possible. Okay. So the second option is your debug sessions. So this is where you can set your row limits when you're doing your table counts. Okay. You can set it up using a table as well. But to be honest, I haven't used that option just yet, and that's something I'll need to play with. Now, if you look at this column here, where it says the data flow debug IR, okay, so what that basically means, so when data flow runs, it runs on an integration runtime. So this is what decides whether it's running on a dedicated Spark cluster that Azure Data Factory provides for itself, or if it's something that you have created as part of your bucket so that everything runs on that. Reason for that is two bound. So by default, it comes with an auto resolution runtime. So like I said, so when you can execute things on it, you can debug on it, you can go into production on it. It's all fine. Problem becomes every time you run anything against that auto resolve runtime, it stands up a Spark cluster. So if you have multiple mapping data flows clusters running, for each flow that it starts up a new cluster. So you're looking at 5 seconds load time every single time for your mapping data flow. And if you've got a large piece of ETL, that quickly adds up to a massive performance overhead for you. Okay, I'll show you there's a way to get around it, and I'll take you through that as well. One of the other things that mapping for data flows does provide you, which I haven't implemented here, is the option to actually set it up using parameters. So you can run your entire ETL, so your copy structures, your whatever you have in a traditional Azure data warehouse, your mapping data flows everything can be controlled by using parameters. This can be stored in the database. You can put it into an Excel file, store it on blob storage, and run it that way. Can you hear me?
Yes.
Yeah, but we are a little bit shy.
Okay.
I think we have taken advantage of this break. Craig shot a question. He said 5 seconds or 5 minutes. That's the question. Does it take 5 seconds or 5 minutes?
5 minutes, I think. Yeah, you're right. Sorry. It is 5 minutes, not 5 seconds. So yes, it is a long time, but it is 5 minutes and not 5 seconds. My apologies.
Thank you.
Okay. So if I just close this back up. So like I said, you can run it using parameters. And I have a client who's done this, and they're running their entire ETL process using parameters in the database. Okay, so why? Just give me a second. I'm trying to see why I can't close this. Anyway.
You have to click cancel.
I think the Zoom window is blocking my cancel button. That's all. Okay. Now, what this also provides you, Microsoft has set up the ability for you to look at the code as it generates it. It's pretty much a JSON string that it runs in the background. I've tried editing this. Sometimes it worked, sometimes it didn't. Generally speaking, I would suggest go into your pipelines manually and make the changes that way. It's a lot easier, at least that I've found. Okay. So what I'll do before I get to the second demo quickly, I'll show you quickly what my connections are like. Okay. So if you look at this, I've got 2 link services and I've got an integration runtime. I'll tell you what the differences are between them. So I'll start with an integration runtime. Now, what an integration runtime is basically like your environment where it runs your code. Now, what I mean by that, so if you look at this is what runs my mapping data flows. So it does 2 things. These are the set of servers that my copy tasks occur on. And these are the set of servers where my Spark ETL runs. So what you can do, you can set the compute type, you can set the core counts, and you can set the time to live. Now the compute type pretty much is your VM server and the type of VM server you want to run. So there's general purpose, there's memory optimized if you're running high-end ETL processes for AI. And there's graphics one as well, I believe. Okay. Then the core count. Now the core count's interesting. So the core count pretty much says how many your VM, how much workload are you going to be putting through it? The smallest amount you can create it with is 4 cores. Now the time to live. So the time to live factor is pretty much how long will this VM in the background be active for. Now the reason I've set it to 10 minutes, and again that's the smallest amount. So if I run any mapping data flows against this particular runtime, I only need to start it once. So after the first 5 minutes where this one starts, anything else run against it will only, will not incur that extra Spark cluster creation charge, or that time. I'll go into the billing as well, but billing is basically based on the compute type and how long it's been running for. And that's one of the caveats you'll notice straight away. When you're doing this, you need to be aware of your cores, and you need to be aware of how long your process will run for, because you will be charged for it in the same amount. If you're running it in Azure Data Factory, you don't have this problem. The reason being, you already have a database provisioned and you're using SQL Server Stored procedures to do them. But in the same way, and if you use a Databricks, you will need to be aware. Again, it's a similar sort of concept to Databricks, because Databricks will charge you based on the amount of time it takes to run your process. So it's the same concept. So if you're using Databricks, or if you're using mapping data flows, you'll be charged in a similar sort of way. Okay. Let's click cancel. So another question, one of the questions we had before was, can we connect to a local server or on-premise server to ingest data? And the answer is yes. So how you would do it, you would come in here, you would create a integration runtime, okay? And then what you'd have is these two here. So you'd have the option for a self-hosted runtime. I haven't needed to use the linked self-hosted runtime before, so I haven't done that before, so this is something I can't speak to right now. So with the self-hosted runtime, basically what it does, pretty much works similar to how the Power BI works if you're running it if you want to connect to data on-premise. So what I mean by that, so the Power BI gate uses is an application called a gateway sitting on a server somewhere, and it maintains a connection between your local on-premise servers and Power BI to publish data. In a similar sort of way, Azure Data Factory has its own integration runtime services that runs on a server. You install it, you forget it, and you basically base a connection off that. And you can connect data between your environments and import them in that way. Now, there is another option what you can do. So if you already have a ton of ETL running on your source systems, okay, so you have a lot of bespoke processes you've built in SSIS, you don't want to lose them, they're mission critical, you still need to run them even if you're in the cloud. What you would do is you would do a lift and shift exercise, and you run your SSIS packages in Azure. Okay, the only thing to be aware of, you will be charged quite a lot in this method. Okay, it can be done if it's mission critical. I'd suggest only if it's mission critical. Otherwise, I'd suggest re-engineering it for Azure and to Azure Data Factory separately. Do we have any questions?
We don't have any questions at this stage. Just a clarification from Greg Lowe. So that linked self-hosted integration runtime that you showed before, that is going to allow you to share self-hosted integration runtimes between Azure data factories.
Oh, right, nice.
Yeah, so imagine that you want to have one that you can reuse across multiple dev environments. That could be a use case. Not recommended, for example, to use the broad one for your dev environment. Yeah, yes. It is handy.
Yes.
Actually, it's Greg. Yeah, one of the things that is a challenge with that, though, too, is it only lets you have 20 concurrent things going on. That's the maximum you can set it to for an on-premises, one of these self-hosted gateway. So the thing is, if you start sharing it between lots of data factories, you can quickly run into that limit.
Right.
And the weird thing that I've run into is then you have things that won't start in your data factory and you can't work out why.
Wow.
Yeah. Cool. Okay. Just a quick note. This is something I found out by accident. So if you're looking at your Azure Data Factory pipelines, each pipeline, there is a limit into how many activities you can have. So what I mean by activity, so each one of these that I've selected is an activity, okay? So there is a max limit on how many activities you can have within a pipeline, and the limit is 50. Okay, I haven't hit that limit yet, but for complex ETLs, I'm pretty sure somebody will hit it. So just be aware that you've got 50 pipelines and it throws an error. That's probably why. Okay, so we'll look at the second demo. So the second demo is a bit more involved. So the pipeline itself is fairly simple. So again, I'm just calling one mapping data flow. Okay, if I look at the second mapping data flow, you can see it's doing a bit more. So I've got a bit more activities sitting in here. So what this is doing is your typical data warehouse scenario where it's doing change tracking and it's only loading in new rows that needs to go into data warehouse. Okay. So how would I do that? Again, similar to what we had before, you come in, you have a look at your source systems, you have a look at your data. Okay, so while that's running, you have your target. So this target at the moment is currently empty. There's nothing in there. So just to prove that, if I run this, there's nothing. It's just waiting for that to finish. Yeah. So I've got a couple of additional tasks here. So this is the old derived column task, I believe, in SSIS. Again, you have something similar, so you can add new transformations, you can have new columns, you can rename columns, you can aggregate your data, any sort of columns you want to create, change, modify, you can do this here. You can also put in parameterized columns. There's a whole different variety of things you can do. Okay, so the new row. So what the new rows is pretty much similar to an exists statement in SQL. So what this is doing is checking my source system and saying, is there a matching column in my target? If it doesn't exist based on the customer ID, then it'll go to the new process, which is create a new record. Otherwise, it'll just drop it out of the environment. Okay. So if you look at this new rows, again, it's what I said earlier. So if it's what it does, as a piece of code, that's the only piece of code that I've added. I've said if my previous columns are true, then insert them, otherwise don't. Now if I just cancel out of that for a second. So if I go back to this, the way to check this is if I run that step, and provided there are no issues, it'll bring back a set of data for me, similar to what we saw previously in the previous demo. Okay, so give it a second. So what it'll do, so if you can have a look at the top of the window here where my mouse is, so pretty much you've got icons saying this will be inserted, updated, and deleted, or upsets, basically. So each one of them will be tagged as based on your criteria, and you can tell at a glance what's happening with your data. So visually, you can say, look, I've got 190 rows. In this scenario, all of them will be inserted because the target table is empty. These are all my columns. This is my data going in. If you had aggregations, you'd see the aggregations as well, as columns, basically. So you can verify as we go. Okay. So what this statement does when it says true, it'll go in and say, for each of these records, which of the conditions is true. The condition is pretty much this, that it's looking at. And the execution of this. So if this condition is true and it doesn't exist, then it'll set it up as insert only. Now you can set up multiple of these conditions. You can say if it's not true, then update it. You can have custom conditions built in. So this is a fairly basic one, but you can write your own expression in here. So it's minimal coding. So you need to understand some logic when you're trying to insert this data, but it's not like you're writing entire streams of Python code to achieve this environment. And then what this does is pretty much similar to what we had before. It's just going to do inserts. Okay, so you can define what you need it to do. You can do allow updates. You can allow inserts. You can, and how you would do this, you would control it using this particular task, which is an alter row task. So you can say upsert. You can say deletes. You know, so you can. But you can't do delete and upsert at the same time. So if you wanted to do a delete as well as an upsert, you'd have another condition in here. So you can have multiple conditions. And these are the ones that are predefined out of the box. And these are the ones you can use to do that. Okay. And again, once your upserts are done, you can run pre-scripts or post-scripts as well. So say, for example, not including deletes, say you had a whole bunch of rows that you wanted to set their flag to -1 because we're old, you can set them here. Once you insert them, you can do deletes of those rows, whatever the case may be, you can do. But this is where a proper SQL statement will go in. So a little bit of coding is definitely involved, but not much. Okay. Again, similar to before, you'll set up your mappings and stuff like that here as well. Okay. So once you come to your data sinks, so similar to what we had previously, you can see that it will tell you what it's trying to do. So whether it's doing inserts, upserts, or deletes, it will tell you that information and you can track what it's doing. In this scenario, it's only doing inserts, so there's no particular icon. But if you're doing upserts, it'll tell you which one's a delete and which one's an insert and which one's an update. So for debugging purposes, it's a great way to go. And this sort of flexibility is not, this sort of debugging and you getting upfront information as to what's happening is not possible with using SQL Server stored procedures. You can do it if you know SQL Server, but there is no visual way to know. But this gives you that visual indicator. Also gives you, if you're looking at data that you want to insert and you want some stats out of it, just because you're doing data profiling and stuff like that, you can do that directly through here. You don't have to go to a third-party tool. Again, this is based on the data that's being provided to this mapping data flow. So if you need to make any decisions as to, my data type is wrong, I think something else is wrong, go and have a look. Easy to play with and just change on the fly. Okay. So are there any questions about that?
Not any questions at the moment in the chat.
Okay, cool. So yeah, so like I said, so if you come back into this and you run it, it'll run that that mapping flow. If there are no issues, then it'll execute it. You'll get information. You can track it. Okay. Also, one of the things I've found is when it is running, there are certain instances where it's easy a mapping data flow to actually find what it's doing. So if you go in, as you can see here, for each one of those tasks, it just tells you what it's trying to do. And each one of those steps, you can see how many records are being impacted, what's being impacted. Okay. In this scenario, because it's only an insert, the source and the target should match. Okay. Since it's the first run. And the second run, once these don't match, then you'll get zeros. If you had deletes, it'll show you how many new rows were there, how many were deleted, and how many were updated. So you have a full tracking history while you're doing your development and before it's released into production. And again, like I mentioned previously, most of this information you can write into a database so you can actually run reports on top of it later.
I have a question in the meantime. It's one of my questions actually. Yeah. From what I've seen in this presentation, before you jump into that red arrow, whatever, is that you haven't written pretty much any lines of code but the expression, correct?
Yes, that's correct.
That's what brings the topic when you say the topic for the session actually is codeless. So you've shown already that without pretty much having any background on coding, you can develop data integration solutions.
That's correct. So yes, you probably won't give this to a business user to do without some knowledge. But again, it is not preventing you from giving it to a business user as well. So it's, somebody new to this can jump in straight away and say, look, this is what I want to do. Granted, he will need a little bit of background in data and what you're trying to achieve. And it's not purely a business tool, but it can be done. It's not such a huge jump, I don't think.
Understood. Thank you.
Okay. And in the meantime, so one of the good things that I found about Data Factory is it actually gives you a very detailed error as to what is happening. Now, in the case for this, it's my database that is a problem, and I'll have to update the identity column. Okay. So things like this, pretty much, you would set up a pre-copy script to say, if I go back in here, correct me guys if this command is not wrong, is wrong.
I don't know. I can Google it.
Yeah, I might have to do that as well. But anyway, so you do something like that and just validate some errors, and I'll try running it again. Just give me a second.
The only difference, so it seems to be right, unless you need to include the name of the table.
Yeah, we'll see. If it throws an error, I'll put the table name in. But again, as you can see, it's minimal coding. Yes, you need some knowledge of database code as well when you get errors like this. But it's few and far between, and you are getting decent error messages out, which was one of the major limiting factors of SSIS that I found. Okay, so while this is running, so another good thing about using Azure Data Factory in general is Azure Data Factory out of the box integrates well with source control. So you can either source control using Azure DevOps or Git. And I'll cover that in a future topics, but know that it can be done. Okay.
So that's probably one question that we're starting to get asked a lot. So the DevOps Git question, originally when we moved to Azure, everyone said DevOps is the way to go. But Azure, a lot of Microsoft seems to be moving away from DevOps and just purely doing Git. What's your feel on, should we be moving away from DevOps, or has DevOps got a future?
A little bit of both. So pretty much if you look at DevOps as a field, not so much as a product.
Yep.
So Microsoft provides you two products, and it is confusing. Okay, so you have Azure DevOps, which is their old TFS Foundation server that they've rebranded, made some changes, it's up there. And obviously then you have GitHub, which Microsoft acquired. So both of them work well. There are limiting factors with both. So if you're an individual developer and you're source controlling your code, I'd suggest going to GitHub because it's free. Some of the tool sets that you can do pretty much what you do in Azure DevOps and GitHub. Not everything, but some things. Now, where Azure DevOps comes into the picture, it's a much more robust tool compared to GitHub in terms of work, task tracking, burn ups, burn downs, all that sort of thing. There is extra functionality thrown into Azure DevOps at the moment compared to GitHub. Your automated release pipelines and stuff like that as well are again better defined in Azure DevOps than GitHub. Not to say you can't do it in GitHub, you can, definitely can, but it's for a business, Azure DevOps I've found is a lot more robustly built at this point in time.
Perfect. Thanks for that.
Yep, no problem. Okay. So it's okay, I'll need to have a look at this statement. But yes, so even though it's errored out, pretty much as you could see, when you looked at the mapping data flow, I know this code will run. The reason for that is, I am getting some data out. The reason it's not working at the moment in terms of inserting into the table is this query is wrong. Okay, so it just gives you a good way to check at what point is your data causing you a problem. Okay, so I think let me put this.
So you'll need to put, I think, pointed by Greg Lowell again to put the table before the on. Actually, just copy the table before the on, or delete the on and put it at the end.
Yep.
That's it. Yeah. So we are 30 attendees today looking at peer reviewing your code. No worries. You have backup.
Perfect.
Yeah, it's a bit like peer programming on steroids, isn't it?
Yeah, I know. Peer programming is great. It is great. Definitely is. Okay, so I'll run this. So while it's running, I'll probably might go back to my presentation and just come back to this in a minute. Okay, just give me a second. See how it goes. Hopefully it shouldn't take too long to run.
Anybody has any questions around this topic at this stage? Who wants to raise the question in the chat or so?
So while it's running, I'll come back to this, I promise, even if there is an error. I'll just go back to this one. Okay, so some of the pricing considerations for this. Okay, so one of the big gotchas when you start using mapping data flows, like I mentioned before, if you start debugging your code, you will be charged money in mapping data flows. The reason being, it is starting up a proud cluster for you in the background. So just be aware of it. Again, it's not too dissimilar to what happens with Databricks. Okay. The billing is based on the type of compute and the number of cores selected per hour that you do. Okay, the settings that I've run, I'll be charged for the 10 minutes that my service is running. So that's why you want to get your code as performant as possible, so you limit the amount of time your services are run. Yeah. So some of the advantages of mapping data flows. So the barrier to entry is low. So as you can see, anybody who knows a little bit of what they want can come in, drag and drop it. You know, it's quick and easy to do. Yes, it'll take a bit of time to do data testing, but the actual building of your process is fairly simple and it's fairly static. Once you know your process, you can make it a template and we can reuse them multiple times. It's a graphical user interface. You can build any length of complicated pipelines with them. So you can, like I said before, you can do NoSQL databases. You can do inserts into machine learning scripts. You can pull data from machine learning, however you can. It's very tightly integrated with source control. It's being actively developed. So there's new information coming out on almost on a regular basis. Case in point, some of the expressions that you saw, the actual builders, the UI elements of it was changed recently. I think there was a couple of changes that came through a couple of days ago. And the program manager for Azure Data Factory is very responsive if you have errors to actually track down. So it's very well managed at the moment. And again, it uses Spark architecture, Apache Spark architecture in the background, okay, which is a standard one. But typically, you will not need to actually even know Spark to see how it works. All you need to do is drag and drop them. Okay.
Just a couple of questions in the chat. So how many of your clients are using mapping data flows?
There's one client that I'm 100% sure of is using them. There's a couple more that are potentially using them. So we're trying to get them to use them.
Yeah. And Andrew's made a comment that there's hardly any, most due to cost. Is that the barrier that you're finding as well?
So is barrier to cost, or sorry, could you?
Yeah. The barrier to moving to data flows is mostly due to the cost.
No, so the barrier to it kind of depends more on what environment you have. So what I mean by that, right? So if you already have invested quite heavily in datafactory, in Databricks, you have a lot of code, then you're pretty much likely to stick with that code. Yes, you can switch, but that will be one of your barriers. If you're migrating your code from using Databricks to using Dataflows, because that'll involve a lot of rework. If you're doing a greenfield project in data warehouse, then I would suggest going that way, using mapping data flows, because it's a lot easier to set up. Again, it kind of depends on usage scenarios. Okay. In the same way, so if you're talking about why you wouldn't use mapping data flows, is you lose flexibility. It's good that you can do drag and drop. It is good that you can only put in expressions, but if you have a lot of complex processes that are already built, you don't want to actually migrate them to mapping data flows, again, because of the cost factor. Okay.
Yep.
Now, one of the things that also gets impacted by this is mapping data flows is purely a Microsoft product. All right. If you want to transfer your code to another cloud provider, then you can't move your mapping data flows. It's not possible, at least at this point in time, unless you've got hybrid cloud. I mean, that's a whole other scenario. In which case, you would put your code in Databricks, because Databricks is portable, because it's just a Jupyter notebook. Okay. The other biggest thing that I find with Azure, specifically Azure and even data flows as well, you've got a potential to get hidden cost shocks. The reason for that is, as a developer, somebody will go in and somebody will start running code. They will debug them. They will write complex pieces of code. They will not be aware of what the pricing model is underneath, because it's not visible to a developer. It's only an admin that has a chance to look at it. And if something is not configured right, or if you forget something, at the end of the month, you will have a potential bill shock coming through. I'm not saying that's going to happen, but that is a possibility, and it's a huge possibility.
Yeah, it's a pretty common possibility I've found with Azure, of the people running it or using it not necessarily understanding how much the executing something costs, or how much something runs up. There's a question based on that as well. How do you suggest to reduce cost during development cycles and debugging? Is there any?
Okay, so what I'll show you, I'll go back to my architecture here. Looks like it's failed again. So this is something I'll have to have a look and see why it's failed. It's most likely due to that. So maybe I'll have to change my table structure. But anyway, where is it? Okay, so typically what you would do. Okay, so if I go back into my runtimes here. Okay, so if you look at this, I've got two runtimes. So this is the default one that Microsoft provides when you start up Data Factory. So it gives it to you for free, or it creates for free. You don't have to worry about it. It's an auto-resolve one. It runs on 4 cores and it runs for 0 minutes. So 0 minutes says, I will run all the time or I'll stay shut down, and every time I provision it, I'll start a new one. Okay. Now, this may or may not be good. If you only have 1 or 2 pipelines, this is not a bad option. Let's go that. So what I've done here, so this is what I use with my client to actually limit their prices. So what I need to do is basically choose my compute type. So compute type, by and large, if you're not running heavy machine learning algorithms, just leave it on general purpose. You'd set your core counts. Again, this depends on your workload, and you'd set the time to live factor. Okay. So what the time to limit factor does, it limits the amount of time your virtual machine is running and the amount of time you're consuming resources. So you will be charged for that 10 minutes. If you're not running any pipelines past that 10-minute mark, it'll shut your server down or that instance down. And if you run another one, it'll just restart it. Okay. So you're losing a bit of performance and time to actually start your debug sessions, but you're saving money in the long run. Okay. So if you are debugging and if you want to debug, probably the best bet is to go set up your own integration runtime, set it to the smallest amount of time to live. It doesn't have to be 10 minutes, it can be 30 minutes, whatever your scenario may be based on your requirements, but set a minimum time to live for your service. That'll limit the amount of money you get charged at the end of the month. Does that answer that question?
Yeah, I think that covers
Just
good
to
explanation.
the other one, the other tip will be to get them right the first time, so you don't need to debug a lot.
Yes.
Yeah.
Well, but I mean, with those, I mean, you will have the potential to change them as you need to go. So actually, if I go back, so if you look at this, okay, there is no way to once you have created them, you can't actually change them. I've found. So yes, you can set them to auto-resolve, but the data types you can't change. So what I'd say is, if you want to create another one which has more, more cores, lives longer, each one of those scenarios create a runtime. Okay. And what you then do is, if I go back to my mapping data flow at the moment, which is this one. Okay. If I go into settings, you can say what the data flow is, what integration runtime it's running on. So the one I had it on previously, as you can see, was general purpose. So this one runs it creates one every single time. What I can do is set it to the one I've created. The options go away, and pretty much it's running on mine. So you know for a fact what runtime it's using and how much you'll be charged. If you had multiple, you can say select one of those multiple runtimes to run. So you could have multiple runtimes. Say you had a job that was taking 3 hours. You need the resources to cater for that. You'd create a runtime just for that. Everything else will use a cheaper runtime. So you can come per pipeline and per data flow. You're limiting your costs. Right. Any questions about that?
We'll have one coming up shortly. I'm trying to get some additional information.
Okay. So pretty much if you want to learn more about this, I've found quite a few pieces of information that is useful. So there's a YouTube channel that's updated quite regularly. The product team for Azure Data Factory and mapping data flows in particular put up topics on a regular basis. It's quite full at the moment. There's quite a lot of topics that you can look at. I found it to be very useful. So the product manager goes through each one of the scenarios and each one of the tasks that are there, that are available in mapping data flows. The second one on that list is the blog site for that product manager, where again, he posts quite a lot of useful information. So things like actually taking your audit data and putting that into a database, and complex examples like that are given on that website. So I'd suggest reading it. It is very good. Microsoft, for the third one, Microsoft recently released a Microsoft Learn, basically learning path for Azure Data Factory. Now, I can't personally speak to how it is, because that's one of the things I will need to look into, but it is also a pathway for you to learn more about Data Factory if you need to. And obviously the last one is Microsoft Docs. So Microsoft Docs has a ton of information around each topic. Downside that I found to Microsoft Docs is a lot of documentation, for one, and it may contain information you don't need if you're just starting out. I'm sorry about that. You were saying something?
No, sorry, you're right. So we have one more question from Ashok. So the question is, if there is a kind of a validation option within the pipelines, do they build that differently, or does it cost?
All right, so if you're validating it, it doesn't cost you anything. So let's say, for example, I go, okay, let me go in here. Or go to this. Okay. So let's say I do something like this. Go back to my pipeline and go, I want to validate it. It will tell you what's happened, what the error is, and where it is. So if you click on it, it'll take you to the task. It'll tell you what the problem is, and you can see what the error is. So doing this validation is not charged at all. So it's only when you're either executing the pipeline or when you have this set on. So basically it means that there is this cluster standing up in the background. And while this is on, you'll get charged. Okay.
Thanks.
Does that make sense?
Yeah, I think that it makes sense. It's free.
It's free otherwise. The validation is free. And I would definitely recommend, validating your code as much as possible. And like I say, you can also validate that your data and your logic is correct by going to the data preview pane every single time you make a change. So pretty much in conclusion then to my topic, okay? So using a mapping data flow reduces barrier of entry. Okay, it provides a visual way to create pipelines. Auditing features are built in, but again, you need to do a little bit of work to get the audit information out and stored somewhere. But at a glance, for each execution, you can see what the audit information is. And it's a visual development environment for you. Okay. So basically coming back then to the premise of my initial question, is it codeless? I would leave that up to you. Parts of it I find are codeless. Parts of it means I have to put in code. So case in point, that identity inserts, it doesn't take you away completely from having to write code, but it reduces it by a significant amount. And I guess the question then, whether it's codeless and whether it will replace big data processes in the future, I will leave for you to decide and come back to me with, because it is a useful and it's an interesting topic, because I've had the same discussions around SSIS, like I said previously. And whether we can put ADF into that same bucket is what I'm not sure about. Okay. Yes, are there any other questions?
Hey, are you going to share the PowerPoint deck?
Yeah, I can share the PowerPoint deck.
Even like or a PDF version should be enough, and then we'll shoot the links to the attendees.
Yep, that's fine. I can do that, no problem.
At this stage, there's another question not related to the topic from Ray that we can cover.
It's always Ray.
Yeah.
The off-topic stuff.
Yeah. No worries.
Cool. No questions around the topic at this stage, but let's give the attendees a few more seconds. And in the meantime, actually, I think from part of the organization and the attendees, we are really happy. You've done an incredible presentation. I think that you covered the topic amazingly. It's great to see more sessions about Azure Datafactory, and we're really happy. Thank you a lot, Sarat, for contributing to the community.
No problem at all. Like I said, there's a lot more advanced stuff that can be done using Azure Datafactory. So things like parameterization. You can parameterize your sources, your targets, your integration runtimes, the whole gamut, basically. And the entire complex infrastructure in Datafactory can be parameterized, but that's a whole other topic. Okay. And that's where it gets a bit more fun.
We'll be looking forward actually to have the annual session around this topic, maybe early next year, the first half. I'm really happy to have you again. And For the attendees, actually, before you jump off, if you're going to leave or whatever, I put a link in the chat. Let me put the link in the chat. It is just 3 questions, and one is like a free text one. But if you can provide your feedback around the session for the speaker or the organization, will be really happy as well. That's how we're going to improve.
Yes, please. Any feedback.
And then, yeah, and then you can cover this one actually from Ray. Separate to this topic, but because you are one of the organizers of the group, so he's asking which one is the date first. What's the date for the Brisbane AI Bootcamp, and which one is going to be the forum for the event? Are we going to use Meetup, Eventbrite, or something like that?
So the next session for the Brisbane AI user group will basically be running on. We have it set up on the Meetup. So if you sign up on Meetup, you can join us. So the next presentation is on the 29th of October. Does that answer your question, right?
Yeah, I thought so. Brisbane AI also goes as Queensland AI. Is that Nick from something Kelson, whatever?
No, so there's two user groups on AI. So there's the Queensland AI, which is I believe is targeted towards more advanced users, whereas the Brisbane AI user group that I'm running is pretty much dedicated to beginners and intermediates. So all the topics, well, most of the topics are dedicated to that. So if you're new to AI, if you would like to learn more, if you'd like to develop some interest, please feel free to come and join us.
Okay, that's good. Yep, no, I've got it now. Yeah.
You got it?
Yep, sorry. Yep. For some reason, it flicked over to Queensland AI, which confused me. Thanks a lot. Sorry to trouble you about that. Oh, yeah, what's his name from SSW runs it too, does he?
Yeah.
Yeah, yeah.
Okay.
And we have Darren. I don't know if you want to raise. There are a couple of more questions there in the chat.
Okay. Sorry.
Okay, so we've just got one. If I have a task that is moving data from A to B, which could be done either with ADF logic apps, Azure functions, which option would you recommend to go with and why? So it's the old Azure question of Microsoft provides us 4 ways to do something and no real guidance of which one.
Okay, so easiest thing to that. So if all you're doing is moving data, so say from your on-premise environment to blob storage as an example, I would suggest just using copy task in Azure Data Factory. I wouldn't even go down the mapping data flow route. The reason for that, you don't need the extra overhead of standing up a Spark cluster to do anything. Now, saying that, if you're doing any more complex processes, again, that requires that extra piece of grunt, then I'd go mapping data flows because you're standing up a VMware to do that. Okay.
And Dan asked, I think you mentioned not to publish legacy SSIS into ADF and that it would be best to re-engineer as mapping data flows.
Again, it kind of comes down to the criticality of it. So I'm not saying never do it. So if it is highly critical and say, it's a process you're running now, say you want to develop an Azure Data Factory, but it's going to take you 6 months, as an example, then I would move your SSIS packages up there and run those SSIS packages. It will cost you the exact price of which I'll have to get back to you on, but it's a lot more expensive than running purely ADF pipelines.
Yeah, basically you're running what you can be paying for is a 4-core enterprise SSIS instance to execute your packages. And what we've done with a lot of our clients is yes, we will load your packages and that gets you quickly into ADF, but slowly over time, then be re-engineering those to data flows or just to pipelines, because a lot of integration services packages are require no grunt and can be done in pipelines.
And you get better performance out of it anyway. So if you re-engineer them, yes, it'll take you a little bit more time, but you've got great technologies to use to get maximum bang for your buck, rather than SSIS, which yes does something similar, but again, it's a legacy piece of code you've got to maintain.
Yeah, that's I think you both and Greg in the chat you mentioned really good points. I think that question actually, Dan, that could be expanded for 5-10 minutes or even half an hour. I think it will depend on a few factors. I'll give you just to continue with example from Greg Lowe, Sarath, or Darren. If you have a lot of intellectual property existing in your SQL Server Integration Services packages, right? So if you have, let's say I have 1,000 SQL Server Integration Services packages, and you're happy with the performance, so maybe there is no point about refactoring to mapping data flows or pipelines, but maybe you just want a managed SSIS VM for you. And that's where maybe Azure Data Factory, SQL Server Integration Services come into play. It will depend on a few things, actually.
Yeah.
Yeah, David, we try and avoid it every time if we can. Kind of like you were saying, we tend to avoid trying to publish integration services into ADF, but you get people who just have wickedly complicated packages you just don't have time to fix in the meantime. But yeah, we tend to try and turn them into native ADF pipelines instead.
Yeah.
The thing I was going to say, though, is just my question, is the biggest pain I've found at the moment. There's two things I find really frustrating with ADF. One is the data types for variables. That's just crazy, the choice of data types. Like there's not even a number.
This is a C# data types. What are they?
No. Have a look at the data types for a variable. It's like, from memory, it's a string or an array, or maybe a Boolean. I think that's about it.
Yeah.
Yeah. What they are is basically Scala or Python data types.
It's so frustrating when you don't even have a number. Like that. That's really, really hard. The other one that's a big pain for us is just no time zone support in the triggers in ADF.
Yes.
So there's a time zone field, but it will not accept any value except UTC.
I need to open the Google to make sure that I put it right there. That's a big one, actually.
Yeah, no. Oh, the problem is that, of course, not so much in Queensland, but everywhere else where there's daylight saving time, you can't set something to just run at 3 o'clock every morning.
Good point, actually.
Actually, one other thing I didn't cover. So I didn't cover triggers in this, but one thing to be aware of with triggers, you can have an event-based trigger as well. So you can set it up so that you copy a file into blob storage, and that file pretty much triggers your ADF pipeline. Now, this used to be done in SSIS, where you had a file copied to FTP somewhere, and that file would trigger something. You can do the same thing in ADF, but I haven't actually implemented anything like that just yet.
Yeah, good point as well. That's an alternative. I remember, maybe anybody with any questions, and maybe we'll open the chat for everything. So if you want to jump into the conversation, feel free to do it. But I remember, the variables, maybe they're quite limited, but I always had the same pain with the variables. Either with SQL Server Integration Services, it was a little bit the same, trying to make sure that I convert, every time that you had to convert the column from a SQL database, you had to use different data types that you have.
I wouldn't say it's limited in ADF. What I would say is there's a whole bunch of data types that fit into one bucket. So what I mean by that, in SQL Server, say you have int, big int, whatever that is, they all fit into ADF as integer, as an example. I know ADF has all different data types for integer. But
yeah, they all work, but the ones I was talking about are in variables. The only data types for variables are string, Boolean, and array.
Yes.
I've never seen a programming language before that doesn't have a number, basically.
Yes. Oh, yes. That I agree. But I mean, they've tried to simplify where they can. But again, yes, for data professionals like us who are used to dealing with multiple data types, it is an issue, I grant you.
I think the inconsistent thing about that is parameters allow a wide variety of types.
Yes. Oh, yes.
I was about to say, so for those ones who are going to jump off pretty much, yeah, so we're looking for speakers for the upcoming months towards, we usually run actually the first week of the month. This month was a little bit special because we had to allocate the meetup half like a third week of the month or something like that. But we're looking at running another meetup potentially during the first quarter of November, and thinking about what we can do for Christmas actually. And we're going to send a survey to the meetup group to see if we do some light talks or something like that.
Cool. I look forward to it. I should start attending more meetups again. It's kind of very difficult at the moment trying to make time to attend meetups.
You should talk to your boss, mate, to see if you can get some free time or something like that.
No, it's nothing to do with work. It's just more after us trying to.
Was joking. Yeah, he's not here anymore.
I'll talk to him later.
Yeah, cool guys. So we'll open the chat. Anybody wants to share anything or so? Otherwise, we'll wrap up soon. And thank you for attending this Queensland SQL Server User Group one more time. Thank you to our speaker, Sarat, for spending time preparing the presentation and sharing his expertise with us. And as well from Darren Dawson and myself, David, we really appreciate that you're here.
Thank you for having me, for your user group, and for my presentation. For letting me
great
present.
presentation. Thanks, Sarat.
Thank you very much.